This video has three components. In the first part, we'll learn how to d over dt instead of d over dx. That means how to take the derivative with respect to time instead of what we usually do, which is taking the derivative with respect to x. In the second part of this video, we'll solve problems, and I'll show you 3 steps to solving d over dt problems. In the last part of this video, for those of you who make it through the entire thing, there will be a trained seal. In the past, we've practiced implicit differentiation, and when we did these, we were always doing the derivative with respect to x. So for this problem, we would have found the derivative of each of these components with respect to x, d over dx, and we would have gotten 2x minus 2y times the derivative of y, that's y prime, equals 0. And the reason we would get this is because when you take the derivative of something with x with respect to x, you just get to do the normal derivative, which is 2x. However, when we took the derivative of a function with y with respect to x, these variables didn't match. The x and the y did not match. So we took the derivative of y squared as though it was a regular function, and then we chained on y prime because this is the actual derivative of a function with y. Then the derivative of 55 was just 0. Let's take the same derivative, but instead of taking it with respect to x, let's take the derivative with respect to t, or respect to time. The reason why we're doing this is that most applications of this sort of differentiation are with respect to time. So let's practice it. So if we take the derivative of x squared with respect to time, t and x do not match. So we'll take the derivative as though it was normal. The derivative of x squared would be 2x. But then we'll also need to chain on the true derivative, which is x prime. We never used to do this because we were taking the derivative of something with x with respect to x. But now t and x don't match, so we get 2x times x prime. Then the derivative of y squared with respect to time, or t, will be 2y times y prime. There's still a mismatch here between t and y, so we'll get 2y, that's what you'd expect it to be, times y prime. And then finally, the derivative of a constant will always just be 0. Let's look at one more application of this, and let's take the derivative of this function with respect to t. So we'll separate it and take the derivative of each piece individually. The derivative of 2y with respect to t would be 2 times y prime. The derivative of 2y would be 2, and then times y prime because t and y do not match. Then we'll take the derivative of this part with respect to time. The derivative would be 6x squared, but since x and t don't match, we'll also need to have multiplied by x prime. And then finally, we'll take the derivative of this last part, and it's y. The derivative of y is just 1 times y prime, or we can just write y prime. In the con exercise, they don't use x prime and y prime. I find this notation to be simpler, so I use it, but when I write x prime, what I really mean is dx over dt. This is what you'll see in con, but these two things are interchangeable. The same is true for y prime. I write y prime, but they'll write dy over dt, and these two are completely interchangeable. They'll also have regular x, we'll use that, they'll also have regular y. There are 3 steps to solving the types of problems you'll encounter on con. The first step is to fill in the incomplete info. The second step is to take the derivative with respect to time, so d over dt. And the third step is to solve for what they want. This problem says y cubed equals x cubed minus 5. Also, dy over dt equals 2.1. And the question says, find dx over dt when y equals negative 2. To solve this problem, we'll take the 3 steps I've outlined here. The first step is to fill in incomplete info. So what is the incomplete info? They give us dy over dt, they give us y, they want us to find dx over dt, and they don't tell us anything about x. So for these problems, there's 4 pieces of information. There's x, there's y, there's dy over dt, which we're calling y prime, and there's dx over dt, which we're going to call x prime. So for this problem, what did they give us? They gave us y is equal to -2. They told us dy over dt equals 2.1, so we'll put that here. That y prime is equal to 2.1. We don't know anything about x, and we don't know anything about dx over dt or x prime. But we can find out x pretty easily. All we need to do is plug in -2 for y back into this problem to figure out what x should be. So let's plug in -2 and see if we can come up with what x is. Looks like we're going to have 8 minus adding 5 over here, and x will be the cube root of 13. So we can fill out this information and say x is equal to the cube root of 13. And once again, all we did was plug in y to the problem, and we were able to figure out what x was. That's step 1. Step 2 will be take the derivative d over dt. We're going to find out this information later, but since it's not in the problem yet, we'll need to come back to this. So we'll take the derivative d over dt. So this is the problem. We'll take the derivative of this. We're going to get 3y squared y prime, because this is with respect to time. That's equal to 3x squared x prime. And then minus 5, the derivative of that is just 0. So now we have 3y squared y prime equals 3x squared x prime. And now all we need to do is plug in the information from over here to get the answer. So we know that y is -2. We know that y prime is 2.1. We know that x is the cube root of 13. And we're looking for x prime. The question asks us to find dx over dt. This is the part we're looking for. Simplifying this problem at this point is just using algebra. This will be 25.2. That's equal to about 16.59 times x prime. And x prime, or dx over dt, what they asked us for, will be about 1.52. Let's take a look at one more example. 2y equals cosine x plus 3. And in this particular problem, they tell us dy over dt equals 5. X is equal to pi over 2. Dx over dt is, we don't know, that's what they're asking us to find. And then y, we don't know what it is. So that'll be our first step, is to fill in the incomplete info. So we need to figure out what y is equal to. And the way we do that is just by plugging in x to the equation. That's 2y equals cosine of pi over 2 plus 3. So that'll be 2y is equal to cosine of pi over 2 is 0 plus 3, and y is equal to 3/2. That was step 1, was just filling in the incomplete info. We'll get the answer for dx over dt in part 3, where it says solve for what they want. The next step will be take the derivative d over dt. And at this point, we don't really need this part anymore. We just use that to get what y was, but we could erase this if we wanted. Now we'll take the derivative in our second step, d over dt. We'll take the derivative of each part with respect to time. The derivative of 2y would just be 2, but since y and t don't match, we'll also need y prime. Then the derivative of cosine x would be sine of x, but since this is x and t and they don't match, we'll also need times x prime. Then the derivative of a constant is just 0. That's part 2, where it says take the derivative d over dt. Part 3, it says solve for what they want. They want to know what dx over dt is. Remember, dx over dt is the same as x prime. So at this point, we're just plugging in the info they give us to find x prime. We'll plug in y prime, which they're telling us is 5. We'll also plug in, oh, my derivative was incorrect earlier. The derivative of cosine x is just negative sine x, not positive sine x. Some of you probably caught that. So we'll plug in that x. In this case, they're telling us x is pi over 2. And then we're looking for x prime, so we'll need to isolate that variable. We get 10 is equal to negative sine pi over 2 times x prime. Divide by negative sine pi over 2, which is negative 1. And we get x prime, or dx over dt, is negative 10.